Hi everyone. So this is my problem. I'm going to walk you through it. First, we start out with our original problem, and that's stated up here. And then we notice that the not is with all of these terms, so we need to separate that to make it easier. So when we separate it, each not gets paired with its own variable, and the ands become ors, which are plus signs. It's still anded here because those are not connected terms. And then this is just showing this in a simpler version. So we have A naught and A naught plus B naught, and so on and so forth. Our A naught, C naught kind of just gets tacked along as we go through this equation. So right here, with everything got distributed, and I noticed there was multiples of things. So when you have multiples of the same term, you only need one. So they kind of absorb each other, and it's kind of like saying one or one, it's still one. So that's what happened here. And then also with this A naught and A naught, when you multiply A naught times A naught, you just get A naught. So kind of the same thing that happened with the A naught B naught. Instead of an or, it's an and. When you multiply the same term by itself, it's still the same term. And so that's why you see this A naught instead of double A naught or a double B naught here. Now, right here, I just kind of paired things up with each other, and then we see here that this A naught plus A naught B naught gets absorbed into just A naught here. Our B naught just comes down, and then these two terms, I rearranged them in order so that way is in alphabetical order. So we have A naught or B naught or A naught C naught or B naught C naught. Now the A naught gets paired up with the A naught C naught, and the B naught gets paired up with the B naught C naught. So the reason for that is because there's like terms, and when there's like terms, the C naught kind of just gets absorbed by the leading term, and that's why we end up with this term here, A naught B naught. I'll show this in the circuits next. Right, we have made it to the live circuits. This is in Logisim. First we have our equation up here. I put them as the outputs, or broken up into the outputs, so that way it's easier to understand. We have AND gates and NOT gates, or NAND gates, NOT gates, and we have some OR gates down here. So first we're starting off with our big equation, and then it's broken down into our De Morgan's theorem. I'm going to go ahead and just play with the lights a little bit so you know what's going on. So you see how they all lit up and not getting lit up. So what happens is this gets broken up into this down here. So our ands become ors. That's why there's OR gates here instead of AND gates. And did you guys notice something weird? I'll point it out later. Okay, next we have this one. This is the same circuit as on the other page up in this area. Instead of all those NOT gates being here, I added these little circles. So those also mean NOT. It just means NOT before the gate, instead of having a bunch of other NOT gates and making the circuit kind of messy. So I'm going to scroll down so you can see this other circuit. This is simplified from this. This equation up here got distributed, and that's what you're seeing here. And then we have our good old AC, A naught, and C naught. So when we make A power on, the A naught goes away because of this branch here. It's knotted, and this both have to be lit up because it's an AND gate for it to turn on. And then you'll see the same thing happen to B, and then C. Okay, something happened. Did you notice it? I'll point it out on the last circuit. All right, this is our next one. So right here I have these AND gates, and they have just double A naughts and double B naughts. Those actually get simplified into just A naught and B naught. I wanted to show them as a full gate here though. So all these are on right now, and then when we start pulling them off, you'll notice them come on. So we have, let's do like a binary code. So we have 1, and then 2, 3, 4, 5, 6, and 7. Do you notice something with C? It's been happening this whole time. Next, it gets simplified further, so the A naught absorbed the A naught and the, or A naught and B naught, and then we have B naught and B naught C naught, and then we have A naught and C naught. So instead of putting all those NOT gates, I just added these little bubbles again. And right now they are all 0, and then if we turn them to 1, you'll see these start to disappear. All right. So on the C, it hasn't mattered through the whole thing if it's on or off. And that has something to do with the simplified form at the very last thing. All right, so this is the most simplified. This is the gate from earlier that we saw. And then this is the simplified, the very simplest form of this equation. So when we turn on A naught goes away because it's opposite, and same with up here. And then same thing happens with B. And then it doesn't matter if C's on or off because it has no significant impact through this entire equation. And you saw that from the very beginning. So A naught absorbs this C naught, and then it becomes A naught down here, and then this B naught absorbs this C naught, and it becomes B naught down here. And that is the simplest form of our circuit. I hope you found this interesting.